today we'll be looking at the effects around the carbon. Now, when we talk about effects around the carbon, we are talking about those effects or those activities that takes place around a carbon. Okay, so this effect around the carbon is very, very important because it determines the reactivity of carbon and also the physical properties of a carbon. So the effects around the carbon are of great importance, and the first effect around a carbon is what we call the inductive effect. Now, what is the inductive effect? Inductive effect is simply is an electronic effect that deals with the polarization. Okay, what's polarization? If I have a carbon to carbon or carbon to something X bond, this bond here is called sigma bond. Okay, this is a sigma bond. So the polarization, this inductive effect is as a result of polarization of this sigma bond. Okay, polarization simply means this sigma bond, the electrons here will either move to the X or go to the carbon. So the polarization of this sigma bond, either to this X or to this carbon, is what we call inductive effect. Okay, and this inductive effect can be a positive inductive effect. We have what we have the positive and the negative inductive effect. Now, what is this negative and positive inductive effect? For positive inductive effect, a positive inductive effect happens when the molecule or the atoms attaching to the carbon donates an electron into the carbon. So donating this electron to this carbon creates a positive inductive effect on that atom that is donating. So most of the times, the elements or the molecules that can do this are called electron donating groups. So for you to be able to donate electron into the carbon, you must be an electron donating group. And the electron donating groups that we have, there are many, okay? But RQ groups are one of them. RQ groups are electron donating group. Same as hydroxide ion. They are also electron donating groups. So when you have an electron donating group, there are so many of them, and you donate electron to the carbon, okay, what we call that a positive inductive effect. Okay, and this inductive effect, what is the implication? The implication of this positive inductive effect is that it increases basicity and stability of carbocations. Okay, stability of carbocations. Take note of this. It increases the basicity and stability of what? Carbocation. Now, if it increases basicity and stability of carbocations, it also is going to decrease. It decreases the acidity. Okay, so this is the effect of a positive inductive effect. Now, so this is called positive inductive effect. Why is it a positive inductive effect? A positive inductive effect is created when the electron donating group donates electron to the carbon, thereby creating a positive inductive effect on that atom. But for a negative inductive effect, the atom or molecule withdraws electron from this carbon. Okay, it withdraws electron from this carbon and then creates a negative charge here. So this is a negative inductive effect, and molecules that can do that are called electron withdrawing groups. So there are so many of them in the material. You can check, you can see them, but let me give you a few of them. Nitro groups are electron withdrawing groups. Carboxylic acids are electron withdrawing groups. Carbonyl groups are electron withdrawing groups. Cyanides are electron withdrawing groups. So there are so many of them. Even acid halides, okay, they are all electron withdrawing groups. So these are all electron withdrawing groups. So when you have these molecules attached to a carbon, they will withdraw electron from the atom, thereby creating a negatively inductive effect within that carbon. So this is what we call negative inductive effect. Now, the implication of the negative inductive effect is simple. it decrease. If the positive will increase basicity and stability, this one will decrease the basicity and increase the stability of the carbanions, because if it withdraws electron, it is going to balance the electron. Remember, carbanions are negatively charged, so if it withdraws the electron out of it, it will create a stability within that carbanion. So a negatively inductive effect stabilizes the stability of the carbanions and decreases the basicity, and at the same time it increases the what? Acidity, because it is withdrawing electron from it. Okay, so these are the effects of these inductive effects. So the end point is that these effects has an implication on the carbon as to either increasing the basicity or decreasing the basicity, or increasing the acidity or increasing the acidity. At the same time, it has implication in terms of the stability of the carbocations or the stability of the carbanions. Does it increase it? Does it decrease? So these are the points you need to watch out if you are looking at this inductive effect. And also know the examples, as many as possible, molecules that are electron donating group and why they are electron donating group. So when you go through the app and study the material, you will see some of these points I'm making. We should be able to understand what they are and how to be able to use them to differentiate which one is electron donating group or electron withdrawing group, and also at the same time know how to differentiate a positive inductive effect and a negative inductive effect. So if you watch here, this arrow here is showing you that this guy is donating electron into the carbon, but this one is showing that this one is withdrawing electron from the carbon. So this one is an electron withdrawing group and this guy is a negative inductive effect, while this one is an electron donating group and this one is a positive what? Inductive effect. So the next one, the next effect around the carbon is mesomeric or resonance effect. Okay, so the mesomeric effect refers to the electron donating or electron withdrawing effect of substituents through pi electron delocalization in the conjugated system. So this effect, this mesomeric effect, is as a result of what? Movement of what? Pi electron. Remember that the previous one we talked about is as a result of what? Sigma electron. So that's the inductive effect. For the resonance effect, it's as a result of what? Pi electron. And so this determines if a substituent can donate electron to the ring or withdraw electron from the ring. Now, what are we talking about? Let's use benzene as a case study. If you look at a benzene structure, you will see that the benzene has what we call, these are the pi electrons. These pi electrons, they move around, they move inside this place. What I mean is this. For example, this electron can move to this place, and then we have something like this. Okay, we have it somewhere here. We have this and we have this. Okay, so when this electron also delocalize to this place, this one will come to this place. So what we have here will be something like this. We have this here and we have this right here. So why this remains here? Why this moves to this place and this migrates to this place. Okay, so we have something like this. We have this here. Remember, this one is still here and this one is here and this is here. So finally this one can migrate here, so we can have something like this. So we can have this. So we have this is here, this is here. So if you notice, look at this effect. So this is just showing us the movement of what? This pi electron. We call it delocalization. That is the movement. So these pi electrons keep moving inside this place. If you notice, look at how it was here. But right now, look at how it is here. It is moving from here to here, from here to here, from here to here. So this movement is what stabilizes this structure. And that is why benzene do not undergo substitution reaction, but rather it undergoes what? Electrophilic substitution reaction. So the substitution reaction simply means that around this carbon, substituents will either come and replace the hydrogen, substitute the hydrogens that are surrounding it, because you know there are 6 hydrogens surrounding this carbon. So substituents can either come and replace those attachments, and those substituents can either be an electron withdrawing group substituent or an electron donating group substituents. So this substituent determines the position of any incoming material or substances that are coming to attach to this carbon. So the resonance effect is an important effect that can that's in aromatic compounds stabilizes the benzene, for example, and subject it to further reactions and can be able to direct it on a particular reaction to undergo. So remember we said that these effects around the carbon, why we are studying them, is because it determines the reactivity of the carbon and also determines the physical property. So from this effect, the key effect or what happens or what resonance does to this benzene ring is to stabilize it. Okay, it stabilizes the ring and then prevents this ring from undergoing addition reaction. Rather, this ring can undergo what we call electrophilic aromatic substitution reaction, where the incoming substituents, which are the electron donating group or the electron withdrawing group, will either withdraw electron or donate electron to the ring. Okay, so this is the effect. This is the simple summary of what mesomeric or resonance effect is. Okay, I don't want us to go too deep. Okay, let's not go too deep. Okay, so when we talk about, we can also have the positive mesomeric effect and the negative mesomeric effect, just like inductive effect. Remember that for positive mesomeric effect, those ones are the ones that will donate electron to the ring. So electron donating group are the positive mesomeric effects, while the electron withdrawing group are the what? Negative mesomeric effect. So, but let's not go into that. Just know that this is simply involve movement of what? Electron by electron, not sigma electron, by electron. So we can also do an example with this. If you have something like this, for example, something like this, the resonance effect is simply the movement of this electron. This one moves to this place so that you can have something like this. Negative charge here becomes positive charge. Okay, so remember that this will not be kind of a positive charge and a negative charge. So this is as a result of what? Movement of this electron. Okay, movement of the pi electron. This one we call the mesomeric effect, not inductive effect. Inductive effect has to do with what? Sigma bond. But mesomeric effect has to do with what? Pi bond. So the next effect is known as the steric effect. So what is the steric effect? It refers to the influence of the size and the what? And the special arrangement of atoms or group within a molecule on its reactivity. How big or how small a molecule is can affect its reactivity. So this steric effect is as a result of repulsion due to electron cloud. Okay, if the electron cloud in that special arrangement is so large, there could be a form of a repulsion that will distort that arrangement and then either make it not to react or to react faster. So this steric effect plays an important role in affecting the rate of reaction in SN1 and SN2 reaction. Remember when we talked about SN1 and SN2 reaction, we talked about the big barrier. The big barrier is like what prevents it from undergoing that reaction. The substrate. If the substrate is a tertiary alkyl halide, okay, the backside attack of the nucleophile. If the nucleophile want to attack it from the backside attack, remember we talked about the SN2 and SN1 reaction. Okay, one is concerted, one is what? Stepwise. Okay, so that one that is concerted, the concerted reaction, if the nucleophile is coming to attack the substrate from the back and the substrate is crowded with tertiary, let's say tertiary substrate, okay, the nucleophile will not be able to attack the substrate and then send the leaving group out of it. So the size of the atom can affect the rate at which the reaction will go. But for some, the size might not really affect, since in one of the reactions there, just like I told you about SN1 reaction and SN2 reaction, in the reaction, if the leaving group is leaving first and the carbocation is formed, then there is no need for size to affect that reaction, because as the leaving group is leaving, then the nucleophile is coming to the wall, to the carbocation. But if the nucleophile is coming to attack the substrate, and the substrate is clouded with groups that can prevent it from reacting with it, then the rate of the reaction will be what? Will be slowed down. So the size or the groups surrounding an atom or a carbon can affect the what? The reactivity. So, and steric effect is one of those effects that can do that. So steric effect has to do with size or group of atoms within a molecule that can affect the what? The angle, strain the angles, and then cause what we call repulsion. And this repulsion can lead to the molecule getting distorted and then affecting what? Its reactivity and its what? Physical properties. So this is the effects that can happen around the carbon. Remember, the essence of this effect is for you to know their effect in carbon and how they affect the reactivity or the physical property of that carbon. So when you go to the material and read more on the material, you will see more points that you can note down with regards to the effects around the carbon. So we are going to only consider these three effects: the inductive effect, the mesomeric effect, and the steric effect.